Hello friends, Assalamu alaikum. We have seen the analysis of simply supported beam and we have calculated the different structural quantities, bending moment, shear force and deflection manually. Now we will verify our result using a renowned software ETABS. So we will take a new model. We will take use built-in setting with SI unit. Our steel section database will be Indian. Our steel design code will be IS 800 2007 and the concrete design code is IS 456 2000. Now since we are having a 6 meter span simply supported beam, so we will take two grid lines in both x and y direction and our spacing of the grid line will be 6 meter. It doesn't matter either you take 4 stories, 3 stories, 2 stories. I will take 1 story and I will take grid only system. I will say OK. Now it is very simple to define the material in ETABS. So I will say add new material. Our country is India and our material type is concrete and I am having M25 concrete. We will see all these quantities. Our weight per unit volume is 25 kg per meter cube. E value is 25,000. Our FCK is M25. So it is OK. I will say OK. OK. Then I will define the material. Section, frame section. I will delete all the frame sections. Delete multiple properties. I will delete the multiple properties. OK. I will define new property, add new property, concrete section. My beam is B 230 by 600 and my material is M25. Concrete beam depth is 600 mm or width is 230 mm. I will going to modify slash show rebar. Now here we have to do the longitudinal rebar and confinement rebar. Actually it doesn't matter in calculation of deflection. It will be used in the design process. So I am not changing it. However, you can change here and you can add material of like if you want to add instead of concrete, if you will take rebar, so we can add Fe500. Similarly, we can add Fe415 and we can change that. Now we are not changing. We will change it in the later stage. That is on the M3 design beam. I am also not changing the cover because it is not the design problem. So I will say OK. OK. Now I will delete this also. Delete property. Delete. OK. Now I will draw the beam since I have edited my grid line and I have defined the material section. I will draw. So I will draw the beam. Draw beam. Here if we are having the multiple properties then we have to select the property. Now we are having only 230 by 600, so I will draw 230 by 600 and I will right click here, then I will be there in the command. If I will draw, if I will press the escape, then I will be out of the command. I will select this point and I will assign the joint support restraint as pin support. I will apply OK. Then I will select this support, I will apply roller, I will apply OK. Now now here you can see in the 3D window that we have changed the support condition. Now I will select the beam and I will assign the load. The total load applied is 23.45 kg per meter, which is distributed in the gravity direction. I am applying the entire load in the dead load. So this is the triple rated load that we will see later. Now I am applying 23.45 kN per meter. I will say apply OK. Now you can see the load. Here it is written. If you want to see, you can do 3D. So you will be able to see this. I will go into the plan and I will apply. Okay, 23.45. If I want to remove this, what I am watching on the screen 23.45, and I will display undefined shape. I will directly analyze or analysis. It will ask to save the model. So I will go to this PC and I will ETABS. beam has deflected. Here we will see the different quantities: display, show forces, frame PL spindle forces. So I will see the moment. This is the moment 33 and this is moment 22. For the beam, the major moment is moment 33 and the major shear is shear 22. So I will say apply and I will say okay. Now when I will right click here, you can see that actually it has taken, what it has taken is it has added actually into the dead load. Now what we can do is, it has added into the dead load. What dead load was including the beam weight, so I have to change the weight. What I have to do is I have to apply only 20 kilonewton per meter. So I will go assign film load distributed. It is only 20 kilonewton per meter, so it will be 23.45 after application of self weight, as ETABS is automatically calculating the self weight. So now here I will send deform shape, display, show forces diagram, frame PS spindle forces. Now this is moment 33. I will say apply for the frames. Okay, now I will say right click here. When I will right click here, now see our manual calculation is showing 105.525. We are also getting here same. Our shear was 70.35. We are getting the same shear here. And our deflection was 3.8 mm. The same deflection we are getting here as we have calculated manually. So thank you for watching this video.